This video will go over some problems in section 2.4. So hopefully part of what we're learning in 2.4 will be a review, and then we're going to add on a little bit. So if we look at first problem here, this should be something that you've seen before. So we have 5 minus 3y less than or equal to 23y minus 10. So what we need to do is get y by itself. So what we're going to do is we're going to subtract 23y from both sides. So we end up with 5 minus 26y less than or equal to negative 10. And then we'll subtract 5 from both sides. So we get negative 26y less than or equal to negative 15. And then we're going to divide both sides by negative 26. So when we divide or multiply by a negative number, we flip the inequality. So we're going to end up with 15 over 26 on this side. And then what you can do is check to see if you can reduce this. And an easy way to do this is to take your calculator and do 15 divided by 26, enter, math, frac, enter, and then it will tell you whether or not it can be reduced. If the number comes back the same, it means it's in its reduced form. So we'll go ahead and put this in here, and now we can see that we have y greater than or equal to, so it kind of prompts you a little bit. And we can type in 15, and then when you hit divide on your keyboard, it will actually make a fraction for you, and then you can check your answer, and we are good. So again, remember to flip on the inequality when you divide or multiply by a negative number. And then when we're looking at this, if we want to put this in interval notation, y is greater than, so greater than or equal to, so we're going to use a bracket, and then we have our 15 over 26, comma, and we're going up to infinity, and this should help you line it up with your number line. So these are less than, so we don't want these two. Greater than, the only difference between them is this is including the value, this is not. So this matches our interval notation where we used a bracket. So we go ahead and choose B and check our answer, and we're good. So once you get it completely right, you will get credit for it. If you feel like you need more practice, go ahead and hit similar exercise. This is similar to what we were doing in 2.1, where you'd want to get rid of the fraction. So let's go ahead and try this. So we have x minus 4 over 3 less than 11 over 4. We can multiply both sides by 12. So then we get 12 over 3 over x minus 4 is less than 12 over 4 times 11. And again, the idea is that we're going to get rid of the denominator. If you're not quite sure what number will work, so you want the smallest number that both 3 and 4 go into evenly. If you're not sure, you can just multiply 3 by 4 times 4 and go ahead and use that number. So now we get 4 times x minus 4 is less than 3 times 11, or you could just go ahead and put that whole thing in your calculator and get a number. We're going to distribute, and then we're going to add 16 to both sides. So we get 4x is less than 49, and then we get x is less than 49 over 4. So the solution is x, and we're going to go ahead and pick the inequality. So we need less than, and then 49 divided by 4. You could go ahead and use this fraction tool here, and I just use the division key, and we can check our answer, and then we got it correct. Again, you might want to think about the interval notation. We just have less than here, so we know that the highest we can go is 49 over 4, comma, negative infinity. So we're using a parenthesis here. So we're going less than. So it's either this one or this one. But because this one has a parenthesis, which matches our interval notation, we'll choose C and then check answer, and we're good. Okay, so now it talks about solving this using the intersection method. So I'll show you the intersection method, and then you can decide whether or not you want to use it, or what you can do is just find the intersection and then solve this doing what we just did before. So the intersection method, again, it's like 2.1, where we graph the equation on the left side, graph the equation, or the expression I should say, on the right side, and then find the intersection. So what we're going to do here is we're going to go ahead and enlarge this, and I think we can move this out of the way a little bit so we can see what we're doing here. So we're going to graph this equation first. So we're going to graph 5x plus 4, and so what we're going to do is figure out some values for x, and then we'll figure out our corresponding y value. So we can let x equal 0, and then y would be 4, and then x could equal 1, and then we have 9. So again, we pick this linear tool here, and we're going to do 0 and 4, and up over to the right you'll see 0 comma 4, and then we're going to do 1 and 9. And you can again see that 1 comma 9, and then hit enter, and then we're going to go ahead and do the 2x minus 5. So can we make a table? xy, so 0 and negative 5, and then we can let x equals 1, and then we have negative 3. So again, we're going to get that line tool, and we're going to plot 0 comma negative 5 and 1 comma negative 3, and there we go. And then we can see where they're intersecting, and it looks like it's intersecting at negative 3 comma, looks like negative 11. Okay. So if we were to go ahead and solve this, okay, so first of all, the intersection method, what it's telling you is that y1 is this first equation that you graphed right here, and we're looking for when it's less than this other equation here. So we're looking for when this line here is below. If it was greater than, we would want to look for when this line is above. So right here it's below the second expression, this 2x minus 5. So what we want to do is look for where it intersects, which is at when x is negative 3, and then we're going to say that all values less than this number, because it's below for all these x values this way, will satisfy this expression. So if we did it the algebraic way, and actually I shouldn't say long because it's probably shorter. So if we solve this, what we would do is subtract 4 from both sides, and then we get 5x is less than 2x minus 9, and then if we subtract 2x from both sides, we get 3x is less than negative 9. We divide by 3, and we get x is less than negative 3, which is what we got right here for x. Okay, and then because x is less than negative 3, our answer is going from negative infinity up to negative 3. So if we do it algebraically, we'll get the same answer. Again, what the intersection method says is take the expression on the left and graph it, take the expression on the right and graph it, look for the intersection, and then this expression, we're looking for when this line, which is y1, is under the line for y2. So that's right here, and then we can see our x values are going down, so it's going to be less than, so we're going towards negative infinity, and it's less than this intersection point. So what you can do, if this doesn't make a lot of sense to you, is just make this graph and save it, and then solve this algebraically like I just did, and then you'll have your answer. So make sure you do the graph right, and then put in your solution, and then it's negative, and then infinity sits right here, okay? And then comma, -3, comma, cross our fingers, and there we go. Okay, so now let's look at number 4. This one, it's kind of hard, not hard, but once you figure out what it's asking for, it's not so bad. But so I wanted to show this to you so you make sure that you know what it's asking for. So the solution for f of x equals g of x is, and what we're looking for is just the domain. Okay, so it's not looking for an interval; it's just looking for values of x. So where f of x, this is your f of x, and we don't know what the equation is, they can give it to us, which you could figure out, but we just care about what this line is. This is f of x, this is g of x. They intersect when x is equal to 2. So your answer to this one here is just 2. And we'll check our answer, and we're good. So now it's looking for when f of x is less than g of x. So again, in your textbook, if you want to look page 141, there's an orange box, and item number 3 reminds you what you're looking for in this. So when f of x is, the line is under g of x. If it was greater than, we would look for when the line was above. But it's when the line is below, and we're looking for where x, what are the x values doing? As this line is going this way, the x values are getting larger. So we want when x is, and this is greater than or equal to, so we need greater than or equal to 2. Okay, so we look to whether it's just greater than or greater than equal to, less than equal to, and this isn't going to tell us anything. It's going to tell us when f of x is less than, and less than means when this line is below this line, and then the x values starting from this point are increasing. So x is greater than or equal to 2. Let's check our answer, and we're done.